Alright, let us generate the code for the n-bit add sub. First of all, we must create a new Verilog file. Now, if we look at the n-bits add sub architecture, so we can see that we have these inputs. We have X and Y, the controller, which is carry in. We had sum and carry out. And inside here we have our ripple carry adder. So what we can do now, we can just generate this n-bit card, generate this n-bit add sub from this file. So we can just copy this here and save as n-bit add sub. Change the file name to n-bit add sub. Now we have this our carry ins, carry in X, Y, the sum and carry out. At the moment, we don't need this carry in and add out. I will explain why we don't need it. We're gonna use the n-bit ripple carry adder with the instantiation model. So the carry out will come through here. So here the carry ins, we can change that to, because we need, if we remember it, we need the Y need to be second complement. So we can just write here complement. So this is a for Y, and there's 4 bits. So inside here, what we need now is, because we have our ripple carry adder, and then what we need is our XORs. So that's what we need, 4 XOR. So that we can generate to inside here, generate. So we can change the name for the generator to XORs. And change this one here. So because we need to generate the first complement. So what we can see is assign complement. So from each complement of 4 of them, we need to flip the Y. So how we do it, we say each Y element in the array, we need to XOR it. We need to XOR it with a controller. So control, and so we need to change this to the carry into a control, because this should be control. Control. So what we are doing here, we are generating the first complement of the Y, as we explained on the theory for the n-bit add sub. So now here what we generate 4 XOR of first complement. Then we need to generate the second complement. So that one we can do exactly as here. So what we have done now, we have done this portion here. In the ripple carry adder, we need to put this input y and x. So this, by the way, is our first complement. Our carry in should be the controller, and our sum should become out here. And this is going to be our carry out bit. So we can go back here and start generating this. So our controller, our first input here should be the controller, the control, and then our second input should be the x, but here it should be y. Our y is here, the first complement, so this is our y. And then is our sum, s, and then here now we have our carry out. So that is exactly what we have done there. So let's save it and try to analyze and synthesize to see if we have some. First of all, we need to put this as a top level entity and try to analyze and synthesize. Yeah, so it look everything have run correctly. So on the next video, let's us generate the test bench for this file.